Okay, in this video, we're going to talk about acceleration, which is the last of the really important variables of motion to understand. Acceleration is a little bit more abstract than the other ones, so it's a little bit harder to wrap your head around, but it's actually the one that we're going to be working with maybe the most out of any of the variables of motion. So it's definitely worth spending a little bit of time trying to understand its properties. So first of all, as you probably guess, acceleration is a vector, not velocity. Acceleration is a vector quantity, like velocity, like displacement, like position. These are all vector quantities. As a result, it has a magnitude and a direction. Okay, in this case, trying to interpret what the magnitude and the direction mean exactly is a little bit trickier than some of the other cases. There's more, like your first reaction is probably to say acceleration tells you how the speed of an object is changing, but this is actually not correct. Be very, very careful, because if you go back to the difference between velocity and speed, acceleration actually tells you how the velocity is changing, not how the speed is changing. And this is where the vector stuff starts to really become important. Acceleration tells you how the velocity of an object is changing. That is actually a lot of information, because it needs to tell you whether the object is speeding up or slowing down and how much, and also how does the direction of the velocity changing over time. And remember, direction of the velocity is which way is the object moving. So the acceleration also needs to tell you about turning. So the acceleration tells you about whether the object is speeding up or slowing down. And it tells you about whether the object is turning or traveling in a straight line. So that's a lot of information, and as a result, unpacking the acceleration is a little bit complicated. So let me do that by considering a bunch of simple cases, and you'll start to see the pattern of how the acceleration works from that. The real key consideration for acceleration: how does the acceleration vector compare to the velocity vector? What you're going to find is almost everything I say from here on is going to depend on that comparison. So the first thing you want to do is, when you're thinking about the acceleration, also be thinking about the velocity. Which direction is the velocity vector, and compare that to which direction is the acceleration vector. And that comparison is really going to have the most information about what's going on in the object's motion. So for example, okay, case one, the acceleration and the velocity are in the same direction. Parallel is the way we would say that in vector language. If the acceleration and the velocity are in the same direction, this corresponds to the object is speeding up, but traveling in a straight line. Okay. I'll unpack these a little bit more once I give you all the cases and you start to see the pattern. Okay. Case two, what if the acceleration and velocity are in exactly opposite directions? Like one of them points in the plus x direction and one of them points in the minus x direction. In the language of vectors, this is referred to as being anti-parallel. In this case, what's going to happen is the object is slowing down, but traveling in a straight line. Okay, and one thing to note right away, because this is a really, really common mistake that a lot of people make, okay? A negative acceleration does not necessarily mean slowing down, because it depends which direction the velocity is pointing. If the velocity is negative, but the acceleration is also negative, that would actually be speeding up because they're in the same direction. So what's important is not whether the acceleration is like positive or negative, points in the positive or negative direction. What's important is whether it points in the same direction as the velocity or not, which is different. Okay. So those are two possibilities. The other possibility, the other simple possibility is, what if the acceleration is perpendicular to the velocity? In this case, this would correspond to an object which is turning, but at constant speed. So case 1, the speed is increasing, the direction is the same. Case 2, the speed is decreasing, the direction is the same. Case 3, the speed is the same, the direction is changing. So those are kind of the three basic possibilities of what can happen. So you'll notice that the information about speeding up and slowing down is in there. The information about turning is also in there because it's the part of the acceleration that's perpendicular to the velocity that causes a turning motion. And you'll also notice in case 3, it is possible to have an acceleration even though your speed is constant, because your direction of your velocity can still be changing. That's where the difference between velocity and speed becomes extremely important. Okay. So, more general idea, if you want to get a little bit more sophisticated than this, think about the acceleration as having two parts. One along the same direction as the velocity, and this one causes the speed up or slow down, and one perpendicular to the velocity, and this causes the turning of the object. Okay, so that's kind of the general case. You might have one or the other of those, or in more complicated cases, you might have both of those happening simultaneously, which we'll learn how to break that down a little bit more carefully later on. But for now, I just want to give you kind of the overall conceptual idea. So let me show you just kind of a conceptual example, kind of like what I showed in another video for the velocity. Like, let's say we have an object moving along this path. Let's say it's moving in this direction. So it moves all the way along the path and ends up traveling that way. And consider the object when it's at several instants along the path. Like, let's say maybe here, and here, and here. Okay, as it's traveling along the path. Let's ask the question, which way is the velocity? And then which way is the acceleration to determine this path? And I'm going to make the assumption here, just to make this a little bit more doable, I'm going to make the assumption that this is all happening at constant speed. Okay, so the fact that it's happening at constant speed, what that should tell you right away is the acceleration is perpendicular to the velocity automatically, because it has to be in order for the object to be traveling at constant speed. Okay, now, first, let's do the velocity. Let's do the velocity in red, how about? Okay, so first the velocity. Remember, the velocity is going to be tangent to the object's path, so it'll be something like that, and that, and that. Again, let me label these, because this is important. So this is the velocity vector, velocity vector, velocity vector. Now, what's the acceleration vector for these cases? So like, what you want to kind of think about when you think about the direction of the acceleration vector is, which way is the object turning? So like, if you had an object that was coming along in this direction here, so say the velocity vector was like that, if the object was going to be turning down this way, you would need an acceleration vector pulling it in this direction. And conversely, if you wanted the object to turn upwards like that, you would need to have an acceleration pointing upwards. C. So that's what I mean by the turning, that basically you can picture the acceleration vector as like tugging on the velocity vector and pulling that velocity vector, causing it to rotate and pulling the path of the object off of a straight line path. So like, you know, kind of like if you watch like curling in the Olympics, and those guys with the brooms walk in front of the stone and they kind of nudge its path and cause it to curve instead of traveling in a straight line. They're giving it a component of the acceleration vector perpendicular to the path. Okay, so what does that mean here? For the first case on the left, you'll notice that the object is basically being pulled in that direction, like clockwise. The velocity vector is being rotated clockwise because initially the velocity vector is there. Like when it gets down here, the velocity vector has been pulled down in that direction. So the velocity vector has been pulled clockwise, down like that. So that means the acceleration vector here, it has to be perpendicular to the path. It's going to be perpendicular to the path that way because that's the way that the velocity vector is getting pulled. Likewise, for the second case here, we have the velocity vector is pointing to the right. If I look a little bit later in the path, the velocity vector is now going up and right. So it went from right to up and right, which means it got pulled upwards. It got pulled upwards by an acceleration vector, which was pointed upwards. So the acceleration would be like that. And again, up here, we would have an acceleration vector pointing like this because we're pulling the velocity vector down in this direction so that the final velocity can be pointed down this way. So it's getting pulled in that direction. You see what I mean? So that's kind of a way to think about the acceleration vector. Let's do one more just to make sure you get it here. Let's say maybe we have an object up here. Okay, so like which way is the acceleration vector pointed there? So again, the way you would do this, you know, try to pause for a second and try to figure it out yourself if you haven't figured it out instantly. First thing you do is think about what's the direction of the velocity vector. It would be like that. So that's the velocity. And then you say, well, which way is the velocity vector getting pulled? And the answer is a little bit later on, the velocity is going downwards like that. So that's a downward pull. So the acceleration vector would be in that direction. And by the way, another way you can think about this, and we'll get back to this. This is not so important for right now, but this is a point we'll come back to in great detail later. You can think about each one of these curves as being kind of like a circle that the object is moving on, that a circle that the velocity is tangent to. And what you'll notice right away is if I put that circle in there, the acceleration vector is always pointing inward toward the center of the circle. It's never pointing outwards. And that's another way you can think about this component of the acceleration that's turning. If you draw a circle that kind of fits into the path, you see how each of the circles I drew was like on the inside of the path in terms of like how it's curving. Then the acceleration points towards the inside of the path, not towards the outside of the path, if that makes any sense. So that's the kind of turning component of the acceleration. And then again, remember, you have another component of the acceleration which determines how it's speeding up versus how it's slowing down. Maybe I should review that really quickly as well too. This video might be getting a bit long, but this is an important concept. So say for instance, you have an object like this, and the object is traveling maybe in this direction. So that's the object's velocity. And let's say that maybe the object's acceleration is pointing, let's say this way, for instance. Let's say that's the acceleration. And my question to you is the object speeding up or slowing down? And is it turning? And if so, which way is it going to turn? So the way you think about this is, first of all, is it speeding up or slowing down? It is slowing down, because if you draw a line perpendicular to the velocity like that, you'll notice that the acceleration is pointing backwards, that the acceleration is pointing backwards against the velocity. So that's going to be a slow down, because the acceleration is pulling backwards against the velocity. And then in terms of turning, you can see that if I think about the other dimension of this, the acceleration is pulling towards the down and left area. So the part of the acceleration which is perpendicular to the path is going in that direction. So that means the path is going to turn this way. It's going to turn clockwise rather than counterclockwise, because the acceleration is tugging it in that direction. So that's how you interpret the acceleration. So the acceleration is going kind of this way and this way. So this is the part that slows it down, and this is the part that's causing the turning.